call it एक्सटेंडेड फॉर्मूला फॉर एंगुलर डिस्प्लेसमेंट। A2 में डेरिवेशंस आती हैं, कुछ मेमोराइज कर लेनी चाहिए। बाय डेफिनेशन ओमेगा इज इक्वल टू थीटा अपॉन टी, ये ओमेगा की डेफिनेशन है एंगुलर वेलोसिटी की। ओमेगा इज इक्वल टू थीटा अपॉन टी, तो वहां से थीटा सब्जेक्ट बना लें। ओमेगा का एक फॉर्मूला पहले पढ़ चुके हैं, दैट इज ओमेगा इज इक्वल टू 2f। अब ये ओमेगा क्या चीज है? ओमेगा इज एंगुलर,
सर ये तो
ओमेगा इज,
फ्रीक्वेंसी वाली डेरिवेशन थी ना?
हाँ ये उसके बाद है। अब यहां से मैंने थीटा की इक्वेशन बनाई 2 पाई ft। अच्छा ये हमने कर लिया, इसका मतलब है हाँ शायद
Yeah,
आप सही।
the final equation was angular velocity equals 2 pi f.
अच्छा ये
अच्छा
इसका
ये
फाइनल
कुछ
आ रहा है थीटा, थीटा
wait,
इज इक्वल टू 2 पाई ft।
वैसे नहीं, हमने ये वाला हमने नहीं, मैंने ये डेरिवेशन नहीं लिखी हुई।
ठीक है, फिर इसको जल्दी से लिख लें। हैव यू डन इट?
Yeah.
Now, relation between v and omega. What is v? V is the linear velocity in a circular motion. The concept of v is that the object will be happy to go in a straight line. It will be like a tendency to go, but obviously it won't go in a straight line until we release it from the circle. Omega is equal to angular velocity. Now you have to give this heading. Now we start the derivation. Look at the screen, Hassan. V is equal to d upon t. This is the definition of linear velocity. Omega is equal to theta upon t. You merge them for one
So
cycle. Please go ahead.
नहीं नहीं,
या
ओके, क्योंकि मेरी जो डेरिवेशन थी थोड़ी सी डिफरेंट थी। मेरे मेरे वाले के अंदर डिस्प्लेसमेंट था।
हाँ वो छोड़े ना, आप तो ये तो दो तीन ही होती हैं, ज्यादा नहीं होती, हर टीचर के पास एक या दो ही हैं, हम किसी एक से कर लें, अगर आपके पास
So
दो
like
हो
there,
जाएंगे।
so like there are multiple derivations,
हाँ
like
देयर आर
multiple ways to derive.
होती एक ही है, वो देखने में फर्क लगती है, टीचर जरा स्टार्ट डिफरेंट कर लेते हैं। ऑफिशियली एक ही है, डेरिवेशन हर जगह एक है। तो v इज इक्वल टू डी अपॉन टी, ओमेगा इज इक्वल टू थीटा अपॉन टी, थीटा इज इक्वल टू 2 पाई रेडियन, एंड d इज इक्वल टू 2 पाई आर, t इज इक्वल टू कैपिटल टी। ये इसका डेटा है। आप पहले डेटा समझ के बनाना, फिर डेरिवेशन बहुत आसान है। ओके, हैव यू कॉपीड इट?
Wait, sir. Which is theta, which is angular displacement equals to standard distance.
नहीं, एंगुलर डिस्प्लेसमेंट इज एंगल ना।
Yeah, so लेकिन अगर if angular displacement is 2 pi radians, how is distance 2 pi radians?
नहीं, डिस्टेंस तो टू डिस्टेंस, देखो ये डिस्टेंस ही है, रेडियन में डिस्टेंस, इसका नाम रखा हुआ है डिस्प्लेसमेंट या डिस्टेंस, तो ये एंगल की फॉर्म में डिस्टेंस है, रेडियन इज द लेंथ, रेडियन इज लाइक अ लेंथ, बट ये मीटर सेंटीमीटर में नहीं होती, बल्कि ये पाई के कन्वर्जन में होती है। तो वो जो 22/7 वाली रेशो है, तो
अच्छा,
थीटा।
ओके ओके, नहीं नहीं सर, वो मैं रेडियस को रेडियन बता रहा था। ओके, दैट वाज माय
हाँ ये
बैड।
मैं तभी क्लियर कर दिया ना, वो ऊपर वाला R8D है, रेडियन,
जी जी।
और नीचे वाला 2 पाई R है। अब आपने वो कॉपी किया, बताओ।
जी।
नाउ अब हम दोनों को लाकर दोनों में कैपिटल टी को सब्जेक्ट बना लेते हैं। जब हम कैपिटल टी को सब्जेक्ट बनाएंगे तो 2 पाई R और 2 पाई दोनों तरफ से 2 पाई कटेगा, एंड वी विल गेट अ वेरी इंपॉर्टेंट फॉर्मूला, V इज इक्वल टू ओमेगा R। यू हैव टू सी दिस स्टेप। So when you make this little derivation, you have to find the time period from both formulas. You have to equate the time period.
अच्छा आप 1 मिनट होल्ड ऑन करेंगे.
आर यू देयर?
या सर मैं अपनी एक पेन ले रहा हूँ. मेरे वाला की इंक ख़त्म हो गई है. सर तो ये डेरिवेशन हमें ये डेरिवेशन याद करके लिखनी होगी.
हाँ, जैसे ग्रेविटेशन के चैप्टर में आती हैं, सो वी नीड टू रिमेंबर दीज स्टेप्स एंड वी नीड टू प्रूव देम और वी नीड टू गेट देम इन द A2 में खास स्टाइल है कि कुछ फॉर्मूलाज ऐसे हैं जिनको पहले डिराइव करना पड़ता है और फिर यूज करना होता है। आर यू डन विद इट?
ऑलमोस्ट सर. सर आप 2 को काट रहे हैं, आप 2 पाई को काट रहे हैं ना.
यस, दोनों तरफ में 2 पाई कैंसिल किया।
ओके.
Okay. Now, centripetal acceleration. Give the heading centripetal acceleration.
So this is like a new topic, right? Centripetal acceleration.
हाँ, उसी चैप्टर में दिस इज द न्यू टॉपिक. Give the heading.
Yeah.
So now, when an object is moving in a circle, its speed is constant, but its velocity is changing at every instant because as a vector, the direction is changing. That is why some people have bad feeling when they sit in merry-go-round because direction changes. acceleration exists because there is a continuous change in direction. So they discovered that when an object is moving in a circle, velocity as a vector is changing. Due to this change in velocity, acceleration appear. This acceleration is called centripetal acceleration. It is always directed towards the center of the circle. At this, it is always directed. Look, speed is 20, 20, 20. Speed is not changing, but direction is changing. So when an object is moving in a circle, it possesses an acceleration. This acceleration is always directed towards the center, and it is called centripetal acceleration. You have to copy this.
So the acceleration will always go inwards
No, the word invert invert won't be right.
towards the center.
Uh, Directed towards the center of the circle.
वैसे जो angular velocity और फिर उसके ऊपर arrow है, what's it supposed to like show?
ये तो कर्व है ना, ये कर्व का मतलब इट्स अ सर्कुलर वेलोसिटी.
और फिर जो एक के ऊपर arrow है, ये क्या show कर रहा है ये arrow?
एक्सेलरेशन इज अ वेक्टर.
So it's showing the direction.
हाँ हाँ, देखो, नहीं नहीं, एरो जो ए पर अपना एरो बना है वो तो सिर्फ ये बता रहे हैं कि एक्सेलरेशन इज अ वेक्टर.
अच्छा, okay. And same for angular velocity.
हाँ.
Oh, okay, okay.
Okay, have you done it? Copied it?
Yeah, yeah.
So remember this point. Now, these are the two formulas for centripetal acceleration. Acceleration, दो formulas, v square upon r, omega square r. A2 is loaded with formulas. So you have to make a class. You have to copy them. Have you copied it?
Almost, sir. जी.
Now, derivation of centripetal acceleration. I will, because this derivation is not important, but it is a complex derivation, but I will post it for saving the time. Centripetal acceleration is followed by the main topic of this chapter. This chapter is about to finish. This is the main topic. The name of this topic is centripetal force. This is the core. This topic is the core. You have to give the heading.
वेट सो
Centripetal.
सेंट्रीपिटल एक्सेलरेशन के बाद अब न्यू पेज है ना, या सब हेडिंग है सेंट्रीपिटल एक्सेलरेशन की?
No, no, it's a main heading of the same
ओके.
chapter.
ओके.
Now look at this. Centripetal force. The concept is there that circular motion is a forced motion. No object wants to go in a circle. Why? Our planets are obediently following the sun because the gravity of the sun is providing centripetal force. Centripetal force hold the object in circle. So in simple term, centripetal force does not allow the object to escape. So we have a
सो
concept. We have a
सेंट्रीपिटल फोर्स
concept.
इज बेसिकली ग्रेविटी.
Huh, centripetal force is gravity.
शुड आई राइट दिस डेफिनेशन डाउन?
No, no. First, you have to observe the concept. First, you have to see the concept that centripetal force is actually the force which is holding you in a circle. So when you turn your car in a circle, you have to hold the steering so you can provide centripetal force. Centripetal force keeps an object in a circle. Look at the two formulas, MA, mv square upon r, and second formula, mr omega square. I repeat the concept. Circular motion is a forced motion. It's not a natural motion. So when you tie a string by when you tie a stone by a string and drill in a circle, you are providing centripetal force by your hand. So this force, this force is called centripetal force, and this force is always directed towards the center. Can you repeat the concept? In circular motion, you need a force to hold the object. This force is called
सेंट्रीपिटल
centripetal
फोर्स.
force. So now you can copy the definition. This is the core concept. Core concept means that this is the main concept of this chapter. You have to copy this. I'm just coming in a minute. Copy this screen. The first box is F is equal to mv square upon r. Copy this formula. Let me know once you copied the formula. Only box is sufficient.
अच्छा मैं वो
Okay. Now look at the second formula.
वैसे can you go back for like 1 second? Okay, that's it.
Look at this mr omega square.
तो हमने सेंट्रीपिटल एक्सेलरेशन के दो फार्मूलाज का सेंट्रीपिटल फोर्स के दो फार्मूलाज बना लिए
Yes.
and that's it.
Now we summarize our concept. Circular resultant force. Circular motion has a resultant force. It has two formula. F is equal to mv square upon r and F is equal to mr omega square. Centripetal force is always directed towards the center of the circle. Centripetal force is always directed towards the center. So now you have to copy this diagram.
So ये तो बना लिया था पहले ही हमने for centripetal acceleration like a similar formula, like a similar diagram, circle और फिर center की line, but it just had the acceleration and velocity symbols. Other than that, no differences. Sir,
Yes.
मैं कहते हैं हमने ये diagram बना लिया already.
बनाइए.
Yeah, like in centripetal acceleration, if you go back and check, ये आप
लेकिन
एक similar वाला
एक्सेलरेशन,
दिखाया हुआ है.
ये डायग्राम तो फोर्स की है ना,
Oh, okay.
दोनों में फर्क है ना.
Okay, done. Yeah.
Acceleration and resultant force are always in the same direction. So, acceleration and resultant force are always in the same direction. There are some common examples. Remember this concept. The circular motion is a force motion. Objects do not like to stay in circle, so we have to push them for circular motion. For example, this person is holding a stone in circle by the string. When a car goes in a curved path, the friction between the tires and the road provides the centripetal force. Friction, if not sufficient, you can provide banking. The road is slightly curved. When electrons orbit the nucleus, the electrostatic force from the nucleus provides the centripetal force. This is the nucleus. Now, their favorite examples are the examples of the galaxy. When planets orbit the sun, the gravitational force from the sun provides the centripetal force. Look at this solar system. Similarly, when a satellite orbits the Earth, the gravity of the Earth provides the centripetal force. Gravitational force provides two important forces, weight and centripetal force. So in our universe, gravity has two important work. It pulls us, number one, and it provides objects centripetal force. So now you have to copy this important concept for our course. Have you copied it?
Almost.
So there are two important applications of the gravitational force. Look at the satellite. The satellite is there. Satellite is actually in the space, and we are providing it centripetal force from the gravity of our planet. So gravitational force is basically a force. Gravitational force is a force which can hold an object. Now, gravity provides the centripetal force, and if the gravity is not active in a space, you will be in a state of weightlessness. For a cyclist, for a motorcyclist, you have to lean to provide centripetal force. And if you have a taste of motorcycle or bicycle, you can experience this. Even a roller coaster example is very interesting. When it reaches the highest point, people do not fall down because the centripetal force is holding or maintaining the circle. When an aeroplane goes in a circle, the combination of upthrust and weight is there. This is the tilt of the aeroplane, which you must have noticed yourself. An aeroplane maintains a circle. When aeroplane make a tilt, look at the screen and you can recall AS physics. And can you recall why there is L sine theta and L cos theta? What this topic is in A level?
This is components.
Resolution.
Yeah, resolution of vectors. Components. So how does this like
This is actually an idea. This is
जब ये
actually an
टिल्ट
idea.
होता है जब ये टिल्ट होता है सेंट्रीपिटल फोर्स एक्ट्स अपॉन इट आप ये कह रहे हैं
हाँ, जब टिल्ट होगा तो L sin थीटा अनबैलेंस्ड होगा और यही L sin थीटा होगा जो एरोप्लेन को सर्कल में लेकर जाएगा.
so that centripetal force equal to centripetal force
तो सेंट्रीपिटल फोर्स सेंट्रीपिटल फोर्स जो कह रहे हैं the resultant force becomes the centripetal force. So when an object is going in a circle, Hassan, observe this concept. When an object is moving in a circle, the centripetal force is the resultant force. Look at this aeroplane going in a circle. Centripetal force, centripetal force is the resultant force.
Also, like after like you resolve the components, the
Yeah,
resolution of
we
vectors,
got the
your answer
component.
is gonna be your answer will be the centripetal force.
Yes, look at this aeroplane lifting upward. The concept to understand is that when you have to make a circle, whenever you have to make a circle, you need a resultant force in the towards the center. Look, this aeroplane is bending. So here, if you resolve the weight, one part component of the weight will balance the lift force, and the other component will be the resultant force. Now, this is a very good summary, which I will share on the chat, which actually recall AS physics, resultant, subtraction, equilibrium, a very good summary to summarize and read it here in A2 physics, that there are three important situations: resultant force, resultant vector, subtraction of vector, and equilibrium of vector. Can you recall it orally? I can share it. No need to copy it, so save the time. So can you recall it? What we are showing here?
Uh, in equilibrium of vectors, there is no resultant force. Resultant force equals to zero.
Resultant force is equal to zero.
In equilibrium,
Yes.
and in equilibrium, opposite forces are equal. So so the force on the right side is equal to the force on the left side, and upwards force equals to downwards force. In subtraction of vectors, the smaller vector subtracted from the larger vector, and the resultant force is in the direction of the larger vector. And in resultant vectors, we basically do resolution of vectors with the uh, sine theta and cos theta.
Okay. This is the resultant force concept. This is the aeroplane moving in that way. And there are two types of circular motion. One is called horizontal circle, one is called vertical circle. This is a vertical circle and this is a horizontal circle. Have you ever visited this in Pakistan, especially? This very nice thing,
Nine,
circus? No.
nine. So these cars are going on the wall.
Yes, this is called death well. So now in the end, we summarize that in a circular motion, the resultant force is always towards the center. There is an angular velocity and there is a linear velocity. So you have to copy this ending diagram. Have you made it?
Yeah.
These are the formulas which I will post. This is the formula list for this chapter. This is the list of units. A2 contains lot of formulas. So we need proper notes, proper chapters for proper formula list, because in compared to AS, A2 has many formulas. Now we move forward to this was our first chapter, and we have to start our second chapter, which is actually an overlapping chapter. In A2, many chapters are overlapping.
इन
Overlap.
ग्रेविटेशन, जिसके अंदर वो ग्रेविटेशन के अंदर भी आते हैं ना एंगुलर वेलोसिटी.
हाँ, ये सब उसमें लिंक है ना, मतलब ये चैप्टर और ग्रेविटेशन, ग्रेविटेशन और ये चैप्टर दे टुगेदर फॉर्म अ सिंगल क्वेश्चन.
So it's like the first two topics in like AS, measurements and measurements, और फिर वो SI units वाला.
हाँ, लेकिन ये ना कि उसमें तो वो चैप्टर जरा हल्के थे ना, मतलब ये जरा थोड़ी हैवी है. तो नाउ यू हैव टू गिव द हेडिंग ग्रेविटेशन. Gravitation is our next chapter. This is chapter number 2. Please give the heading, take a new page and give a new heading, gravitation. It is a phenomena of attraction originated from mass. Newton was basically behind this. Newton was the first person who proposed that gravity is occurring due to mass. It's like a story that he was sitting in an orchard and he saw an apple falling down, and he thought that why the apple falls down. So he had to idealize that there must be a force which is attracting the apple, and this is the concept of universal gravitation. Gravitation extends throughout the universe. It means gravity is a force which is spread out in the whole universe. So Newton was the first person that he thought that gravity is present throughout the universe and it is holding everything. Gravity provides the pull, the weight. Gravity also provides the centripetal force. So are you there, Hassan?
Yeah.
Okay. So what is the first concept? Can you repeat from the screen?
Gravity is a phenomena of attraction originated from mass.
Huh. This is a phenomena of attraction coming from Newton, and Newton was the person behind it. Second, this gravitation is a universal phenomena. Now, Hassan, why gravitation is a universal phenomena? It means that
Because it holds everything in place.
gravity extends throughout the universe. Gravity extends throughout the universe. It provides the centripetal force. It provides the force of weight. Look at this. A satellite is being attracted by the gravitational force. We put the concept force field. It's a region where a force is felt. We have to copy down.
Okay.
The most common fields in our course: electric field, magnetic field, and gravitational field. So in our course, there are three fields to consider: electric field, magnetic field, and gravitational field. We are starting with gravitational field, which is obviously the part of this chapter. So you have to give the heading gravitational field, G field.
Okay.
Gravitational field, it's a region in a space around a mass in which another mass experiences a force of attraction. So this is the definition. Gravitational field is a region in a space around a mass in which another mass experiences a force of attraction. So you have to see this definition. There is a force field around every mass. So Newton was the first guy who said that gravity is around every mass. So it may be small, maybe large, but this is a regular field. So we have to show it by imaginary lines. These lines are directed towards the center of the mass. This is called a gravitational.
Gravitational field line.
You have to copy this. Okay. So we keep it up to here. Our first chapter is finished.
अच्छा वो
And
साथ में आपने दो क्या बनाए हुए हैं?
वो क्या बनाए हुए दो फ्लक्स लिखा हुआ है,
और उसके नीचे?
वेबर यूनिट. It's a unit of flux, magnetic field, electric field. So we are stopping here and we will inshallah continue in our next class. Allah Hafiz.